Okay, so we're diving into the world of AI and math. There have been all those headlines lately about AI becoming these, like, math geniuses.
Right, right.
And, well, we were definitely intrigued,
Yeah.
but we also wanted to, look a little deeper,
Sure.
which is why we're doing this deep dive into two brand new research papers that really kind of throw some shade on that whole AI is math genius thing.
Yeah, it seems like almost every day now there's like a new headline about AI conquering some new frontier, right?
Right.
But what these papers really highlight is that maybe we need to like tap the brakes a little bit
Yeah.
on all those pronouncements, at least when it comes to like truly understanding math.
Exactly.
Yeah.
So we're looking at these two papers, and they both really try to unpack how well large language models, those LLMs you've probably heard of, can actually handle math. The first one is called Functional Benchmarks for Robust Evaluation of Reasoning Performance and the Reasoning Gap.
Okay.
And this one really made us think twice about whether LLMs really deserve that math whiz title. What do you think?
Yeah, it's fascinating because what they basically do is they point out that all those like amazing scores that LLMs get on these math tests, they might actually be super misleading. It's like, that friend we all have who can like ace a history test just by memorizing all the dates and names. They couldn't tell you why any of it actually matters.
You're just playing the game.
Exactly.
They don't actually
What do you
understand
know?
the rules.
Right.
So how did these researchers, like, expose this possible flaw in how we're thinking about LLMs and math?
So they came up with this really clever concept that they call the reasoning gap.
Okay.
And the idea is this. Imagine you present an LLM with a math problem, right?
Right.
And then you give it the exact same problem, but you just change the numbers in the context a bit.
So, like, if Sarah has 3 apples and John gives her 2 more, we change it to Maria and David swapping oranges.
Precisely. The core problem, the math, it's identical. It's just dressed up differently. And so their thinking is, if a model truly has reasoning skills, it should be able to solve both of those problems super easily. Like, it shouldn't be fazed by those little, like, superficial changes, right?
Yeah.
But if it, like, stumbles on that slightly altered version, then that kind of suggests that it's relying more on, like, memorized patterns and not actual understanding.
Okay, that's actually really clever. So they put these LLMs to the test, right? Using this whole reasoning gap concept.
Yeah.
What did they find? Like, did the LLMs, pass with flying colors, or did they totally fall flat?
Well, they basically created this like much tougher version of this really popular math benchmark called math.
Okay.
They called it naturally math.
Of course.
And the results, well, they were a little concerning, to say the least.
Oh.
They tested out a bunch of different state-of-the-art LLMs on this.
Okay.
And the reasoning gaps they observed, get this, they ranged from a pretty startling 58% all the way up to a kind of jaw-dropping 80%.
Yeah. Whoa, those are some serious gaps. So even the LLMs that are supposed to be like the top performers, the ones that are wowing us with, their ability to do these complex problems, they might actually be relying more on like memorization than true understanding.
Yeah, it definitely throws like a wrench into that whole LLMs are math geniuses narrative that's been going around.
For sure.
And here's where it gets even more interesting. They found that, generally speaking, the more difficult the problems became, the wider that reasoning gap grew.
Okay, so that kind of makes sense though, right?
Right.
Like it's easier to rely on, memorized formulas or just simple calculations when the problems are pretty straightforward. But when you start like cranking up the complexity, those shortcuts just aren't going to cut it.
Exactly. It's like those students who can, recite the textbook perfectly.
Yeah.
But then like you give them a real world problem and they just freeze.
Yeah.
Because their knowledge is like super superficial.
Okay, so we've got LLMs potentially like flunking out of advanced math.
Yeah.
What about our second source? This one is called GSM-Symbolic, Understanding the Limitations of Mathematical Reasoning in Large Language Models.
Yeah.
Did this paper kind of echo those concerns about, how good LLMs really are at math?
So this paper actually dug even deeper into this whole dilemma, and they definitely expressed reservations about those static benchmarks, the ones that basically just test a fixed set of problems over and over.
Right.
They argue that if we really want to understand what LLMs are capable of, we need like a much more dynamic approach.
So it sounds like they're calling for less of a multiple choice and more of a show your work kind of test for these LLMs.
Exactly.
Yeah.
And to do that, they actually introduced something called GSM-Symbolic.
Okay, GSM-Symbolic.
Yeah.
Sounds intriguing. So tell us more. Tell us more about this new benchmark and how it's trying to give us like a clearer picture of this whole LLMs and math situation?
Okay, so think of it this way. Instead of just testing the same problem repeatedly, they're creating variations on a theme. So they make sure that like the underlying mathematical logic of the problem stays the same, but the specifics of it, they change.
Yeah.
And to do that, they use what they call symbolic templates to generate like a whole bunch of different versions of existing math problems.
Okay.
They took these from a popular data set called GSM-8K.
Ah, so they're really shaking things up a bit. This is cool because it lets researchers see how well LLMs can, adapt and apply their knowledge to new situations, right?
Right.
Which is a much better test of genuine reasoning.
Exactly.
So what about the results? What did they find? Did GSM-Symbolic, vindicate our LM friends here, or did it kind of solidify that whole they're just really good at a very convincing game of pretend thing?
Well, you're going to have to fasten your seatbelts here because we're about to uncover some pretty surprising vulnerabilities. So their evaluations using this GSM-Symbolic benchmark, they showed that LLMs, they can be surprisingly fragile when it comes to math.
Exactly.
Like when they just tweaked the numbers within a problem but kept everything else exactly the same,
Yeah.
the LLM's performance totally tanked.
Wait, so they struggled just because the numbers changed. You'd think that would be the easiest part for them. It's almost like they're so focused on the pattern of the problem, you know what I mean?
Right.
That they kind of forget that numbers can change without changing the underlying math. It's like getting hung up on what font a test question is in or something.
It's totally a fascinating paradox, though, isn't it?
Yeah.
Because we assume that, numerical manipulation would be their forte.
Right.
But this research really suggests that they might be clinging to those superficial patterns instead of actually applying true, adaptable mathematical reasoning.
So they're more like master calculators than actual mathematicians.
Right.
They excel at crunching numbers when the pattern is familiar. But their ability to, reason flexibly and adapt to new situations, let's just say there's room for improvement.
I think that's a really good analogy, actually.
Yeah.
And if that wasn't enough to make us question their reasoning skills, the researchers actually took things a step further. So remember how we were talking about the reasoning gap earlier?
Yeah.
They found this really curious disconnect between how LLMs handle numbers versus how they handle words.
A disconnect. Okay, now I'm really intrigued. Tell me more.
So they discovered that LLMs were much more robust to changes in proper names within the problems.
Oh, right.
Like swapping out, say, Sarah for John or apples for oranges. That didn't really faze them.
Huh.
But as we discussed, even tiny, tiny tweaks to the numerical values sent their performance into a total tailspin.
That is so wild. You'd think numbers, the literal foundation of math, would be their strong suit. It's almost as if they're treating numbers more like arbitrary symbols rather than quantities that have, meaning and relationships. They can read the letters, but they don't know what the words mean.
That's a great way to put it. It suggests that they might be leaning super heavily on the linguistic patterns,
Okay.
the structure of the sentences to guide their problem solving, and almost ignoring the numerical aspect altogether.
So they're better at understanding the story than the math behind the story.
Yeah.
It's they can read a recipe and recognize all the ingredients, but they have no clue how to actually combine them.
Exactly. And this actually brings us to a really crucial question that both of these papers raise, which is if LLMs struggle with even basic mathematical reasoning, then what does that mean for their applications in the real world?
Right, because we hear so much hype about AI revolutionizing everything, from healthcare to finance. Are we getting ahead of ourselves? Should we be putting the brakes on all those AI-powered financial models?
I don't necessarily think it's about saying that AI will never be able to grasp math.
Okay.
Or that we should be hitting the pause button on everything. But it's more about recalibrating our expectations a little bit.
Okay.
And really understanding that while LLMs have shown incredible promise in certain areas like natural language processing and, creative writing and things like that.
Right.
Tasks that require heavy logical reasoning, things like medical diagnoses or, as you said, financial modeling, those might require a bit of a more cautious approach.
So maybe not handing over the keys to the stock market yet.
Exactly.
Yeah.
It's crucial to remember that these models are still essentially in their infancy when it comes to this kind of reasoning. And while they can be incredibly valuable tools, they shouldn't be replacing human expertise and judgment just yet, especially not when the stakes are high.
Yeah, it's so tempting to get caught up in the excitement of it all. But we can't forget that these are tools.
Right.
They're not oracles.
Right.
They can enhance our abilities, but not replace them entirely, especially when we're talking about things like complex reasoning and decision-making.
Absolutely. And to bring things back to those research papers for a second, I think it would be helpful to look at some specific examples.
Okay.
Because I think that'll really highlight like some of these limitations in action.
Yes, I'm all ears. I always find that like real-world examples really help make these complex concepts click,
Totally. Remember that problem from the functional benchmarks paper about the letters in the word 16 and calculating the probability of the E's not being next to each other?
Yeah.
The one that they used to kind of illustrate the whole functionalization process.
It's coming back to me. Yeah, it involves some like clever counting and probability, not just like your basic arithmetic.
Exactly. And GPT-4 aced the original static version of that problem. But when the researchers hit it with those functional variants, using different words, but with that same underlying logic, it could only solve 1 out of 3.
Interesting. So even though the reasoning was identical, just changing the specifics of the problem tripped it up.
Yeah. It's like it learned the answer to that specific problem with 16, but it didn't actually understand the underlying concept.
Right.
And then there's another example. This one involves like spinners and calculating the probability of getting an even 2-digit number.
Okay, yeah, I vaguely remember that one. Something about like multiplying the numbers on 2 different spinners.
Right. You got it. And again, GPT-4, no problem solving the static version.
Right.
But when they threw those functional versions at it, it just kept saying no solution for every single one.
No solution.
Right.
That's a pretty definitive answer for a model that supposedly excels at these kinds of problems. Yeah. There's like it hit a wall. Like it couldn't even attempt to apply its knowledge to a slightly different context.
Exactly. And it suggests that, again, that initial success that it had, it might have been more about recognizing a familiar pattern than it was about genuinely understanding the problem at hand.
So it's not just about getting the right answer. It's about understanding how and why that answer is correct. It's about the journey, not just the destination, as they say.
Yes. That is a beautiful way to put it. And I think that really is the crux of this entire debate, right? Like, we can't just rely on surface level performance anymore. We have to dig deeper. We have to understand how these LLMs are arriving at their answers and determine if they're actually exhibiting like genuine reasoning or if they're simply mimicking patterns that they've seen before.
Okay, so we've talked about some pretty significant limitations here, but I mean, where do we go from here? Is there hope for LLMs in math?
I don't think these papers are meant to be like a final exam for LLMs. It's more like they're a wake-up call.
Okay.
They highlight a really, really critical area that needs like a lot more exploration and development. We need new training methods, new evaluation techniques that really push LLMs beyond just surface level pattern matching and move them towards like genuine adaptable reasoning.
So how do we actually like bridge this reasoning gap? How do we help LLMs move beyond just mimicry and into like true understanding?
That is the million-dollar question, right? But some researchers are exploring some really, really promising avenues. One of them is incorporating more what we call symbolic reasoning into the training process. So essentially teaching them to manipulate abstract representations of mathematical concepts rather than just crunching numbers.
So it's about teaching them the why behind the how, right? Helping them actually grasp those underlying principles that govern mathematical relationships. Kind of like moving beyond rote memorization to understanding the elegance and, dare I say, the beauty of these mathematical concepts.
Yes, exactly. Another approach is developing new benchmarks that go beyond those static problem sets and actually test their ability to generalize, to adapt. We need challenges that force them to think critically and creatively, not just regurgitate patterns that they've memorized.
It sounds like we're really on the verge of like a whole new era in AI research. One that focuses on developing machines that can truly reason and understand, especially in that really complex realm of mathematics. It's a fascinating and potentially like incredibly transformative journey. But before we get like too far ahead of ourselves, let's take a moment to just kind of like reflect on what we've learned today. What are your final thoughts on all of this?
Yeah, it really has been like a wild ride, hasn't it? We started off all excited about AI's potential in math, and then those papers kind of threw us for a loop.
I know, right? It's like realizing that friend who's like amazing at trivia night, They might not actually be a mathematical genius after all. Like, they're great at playing the game show, but then you ask them to solve a real-world problem, and they're, like, completely lost.
Yeah.
Exactly. But I do appreciate how these papers, they don't just, like, point out the problems. They also, like, really push us to think about solutions.
Oh, absolutely. And I think one of the most exciting takeaways for me is this whole idea that we need more like dynamic and creative benchmarks. Like, it's about designing tests that actually challenge LLMs to think outside the box. You know what I mean?
So less about can you solve for X and more like, can you explain the concept of infinity? Or like, can you come up with a new mathematical theorem?
And now you're talking. We need to be challenging these models to not just process information, but to actually understand it and apply it in like totally new and creative ways.
That is such a good point. It's not just about teaching LLMs to be like better calculators or something.
Yeah.
It's about like really nurturing a deeper understanding of those underlying mathematical principles,
Yeah.
Which makes you wonder, like down the line, could AI actually contribute to like new mathematical discoveries?
It's a mind-blowing thought, isn't it? Like, imagine an AI actually collaborating with, like, real mathematicians, pushing the boundaries of human knowledge.
Yeah.
I mean, that's the kind of potential that makes this field so incredibly exciting, I think.
It really does. And it makes you think about like the future of AI in general and its role in our world. And I think it's pretty clear that we need to approach AI development with like a balance of optimism, but also like a healthy dose of caution.
Totally. I mean, as we've seen today, these models are undeniably powerful.
Yeah.
But they still have some pretty significant limitations. And I think it's our responsibility to, to really understand those limitations and to make sure that we're guiding AI development in a direction that ultimately benefits all of humanity.
Couldn't have said it better myself.
Yeah.
Though this deep dive has been like a total roller coaster, honestly, full of like surprising twists and turns. But I think the main takeaway here is that while AI's mastery of math might be a little overhyped right now, at least the potential is definitely still there. It's just going to take some time, a lot more research, and maybe like a whole new way of thinking about intelligence itself.
Well said. As always, I'm really excited to see what kind of amazing discoveries await us as we continue to explore this ever-evolving world of AI.
Us too. Thanks so much for joining us for this deep dive. Until next time, everyone, keep asking questions, stay curious, and never be afraid to challenge those headlines, especially when it comes to AI and math.